Got it?
Yep, it's good.
Meeting recording is in progress. Okay, great. So today we will discuss IPS trace log, and there's 3 steps to this. With IPS trace, there is capturing the trace itself, saving it, and then opening it using either IPS scope, which is going to be the main focus of today, and also going through the file and maybe finding data there. So sometimes they're used in conjunction. A very important thing about IPS trace is knowing what IPS is doing. So it's almost useless to get a trace and and then open it and then see what's going on without knowing what IPS is trying to do. So being familiar with the config, understanding what the logic behind it is, and then taking a look at the logs is the way to go, for me at least. So in this session, we will cover, how to use the tool in the first place, just, how to take a trace, how to open files and things like that. And then we'll take a look at an example to show how we can use it to troubleshoot, to figure out if we're getting the inputs that we're getting from the machine builders, and figuring out what's going on timing-wise and signal-wise. A lot of times it's used to specifically see if the machines are doing exactly what we're telling them to do, and if we're taking their inputs and using them in the correct way. So let's start by taking a look at IPS and seeing how we capture the trace in the first place. So we'll start with our old classic tree view of IPS. Yeah, we'll do that. So if you're in tree view,
I want to share your desktop, Tarek.
Oh, I'm not sharing my desktop? Great, thank you. Share desktop.
Thank you.
There we go. Can you guys see my blue desktop?
Beautiful color.
It's shiny. Okay. So if you're in the old tree view of IPS, to get the trace to work, in order for it to be opened using IPS trace, you have to check the details option. By default, it's an overview. An overview basically just shows the most important things, like lot started, aggregation failed, aggregation passed, and it would give you a blurb about that. But in order for you to open with IPS trace and see all the details that are going on, you have to go to the trace menu and choose details. Show all will show more, but typically we'll only need details. Details really captures all the information that we need, where when a particular process happened, the data that this process was handling. So it's even going to show you the number that a find item block is looking for, or the numbers that an aggregation block was looking for in the database to figure out whether they're good or not, things like that. And of course, it will capture the timing of all of these things, how long they took, and there's a specific section that IPS trace will show separately, which talks about the VIC inputs and outputs. So if a customer is having an issue or a field engineer is having an issue and they want to use IPS trace, you got to turn details on, and then after the situation happens, you can save that to file. You can typically save it in a text file. You can save the event log here. You can save whatever you have here in text. IPS trace is separate from the event log. Event log is going to save more details, not just IPS related. So either one is opened by the IPS trace executable. So yes?
We do have, for CCTS, some screenshots of all this, along with a little guide on how to do all the traces and why we turn them on. I'll give it to you after the meeting so you can have.
Please do. because we can use that definitely as part of the resource that we'll hand over to FEs or whatever if they want to use it in the field. So that's great. Thanks.
Yep.
So this is yes.
By default, let's say for the first time you install this software, what is expected to be turned on under Trace? What am I expecting when I install it for the first time?
Well, there's no installation really. It's just an executable that Lee created. Trace, by default, these things that I'm showing you here, they're just part of our software. So if you're using an IPS engine and you're in our old view of IPS, you will see all of these menus, and you can just turn Trace on. I'll show you how to turn it on with our new view of IPS right now. But to use the utility itself, the utility is an executable, and I will show you how to open the files using it. So we'll get there a little later.
To answer Monica's question, basically it's on overview all times. The reason for that is the performance lag it creates. It's taxing on the system. So when we need to capture stuff, that's when we turn it on to the details. But normally it is always set to overview. That is correct.
Okay, so let me show you how to turn on and take a look at these things in our new IPS view. So I'll open this here. This is the case aggregation IPS for this particular system. This is Amgen in Ireland, if you guys are interested. Okay, so typically in order to see the menu, you have to right-click over here in the black space and then hit View Menu. And then here you can turn on which option of trace you want the system to be capturing. Overview is going to be the default one, which captures the very important things and just gives you an overview. Details is really what we need. Show all even taxes the system even more than details, but typically we won't need more than details. And this will just have the system in the background keeping track of these things and saving the data anyway and logging them into sort of a text format. In order to view it, you can right-click in that blank space, hit View Events, and it's going to show you what's going on in the system at the time. You can even use this event viewer to open files if need be. I can open this one, for example, and let's hit this. This will take a while to move over to this side for some reason. And that's the kind of detail that the full the detailed view of IPS Trace will show you. It's kind of giving you a lot of information about what's going on. Here's a vision input, and that's the data that's coming from vision. This is the number that vision picked up. This is the EPC. This is the ORI as it was finding the number. So it's really a lot of information that, you know, if need be, you can go in and try to figure out if there's, for example, any duplicates that were found. You can go back and review all of these things, if that's the kind of issue that the customer has. So obviously a lot of information. And if we need timing details out of this, it's hard to kind of read it from here, and that's why the IPS scope is used. So before we take a look at how IPS scope is going to display this, let's first understand the IPS config that we have. And I'll give you a little bit of a background on what's going on here. Yes, Bob?
Correct me if I'm wrong. I don't know on the newer software, but when you end a lot, it goes back to overview again. You need to actually start your lot, then go and change the details to record the stuff. Is that correct?
I don't know. I don't know whether it will go back or not.
Yeah, the older software, I know you had to go actually start your lot for you to change the details. Otherwise, it would go back to overview. We found it out the hard way by having people turn the trace view on and start their lot and then capture what we needed because it was back in overview again. So I'll have to check with Lee later on and find out the answer to that question.
Okay, cool.
All right, thanks.
No problem. I know when I was doing this project, I didn't have to go back and turn details on. It was always capturing details. That was back in February. They were running 735 100, I believe. Or was it 734? It was even, I think it was even 734. Anyway, this viewer, you have the option of kind of filtering things in and out. Like right now it's showing everything. I can say I don't want to take a look at the critical errors, so it's going to filter that from this view over here. I can turn off major and it's going to turn them off. I can turn this off and now it's not going to show anything because I turned everything off. But basically these are just filters that you can use. You can view from here after it turns these on. Give it a second. You can even have the same filtering options as you have from the menu here. If you want to take a look at the details of anything, you can just double click or use that menu to see the detail of each one of these messages, saying what the record number is, where it's coming from, the date, the time, what category it is, and then the description here. So this is basically how the data is getting captured, and that's how you can view it in a text format. So let's see how this can be useful. We'll take a look at an example where we use this. So let me give you a bit of a background. We had issues on this machine where sometimes aggregation would fail because we didn't see that all the cartons made it into the case. It had maybe 5 layers. Each layer was supposed to have 22 cartons. And basically, the machine loaded it in an in-feed type of way. So a camera would see 2 cartons at a time, and then they would go into a queue. The machine would pick it up and put it into the layer area 2 at a time. So it would pick up 2 cartons and move them in. And if we passed the inspection, it would do that. If we didn't pass the inspection, the 2 cartons move over to a reject bin. And it would load them in 2 by 2, and then after maybe 5 rows, it would just pick up all 5 rows and place them into the case, the whole layer together. And we would notice that sometimes it just, our system didn't capture all the cartons that went in. So we turned on IPS Trace to really understand what was going on, because the case would be full and we would think that it's missing 2 or 4 cartons. So we wanted to understand, why are we missing 2 or 4 cartons? Why aren't we capturing all the cartons that are supposed to be there? Is there some kind of miscommunication between us and between the machine? So this is how IPS works. We got a camera that's taking a look at the 2 cartons. It's seeing the numbers for both cartons at the same time. Create multi is going to now pass the 2 cartons separately into the stream. Find item is going to find both cartons and pass them to the group FIFO here. If both are good, they move forward. If one of them is bad, they both get rejected. And we tell the machine either way the result of both cartons at the same time. And then that's going to have all the rows. When the rows get picked up, it's going to go into the case layer FIFO, and then it's going to go to the case aggregation layer transfer. So that's when it gets picked up and it's transferred into the case. After it makes it into the case, it's going to be in the aggregation block. And then from there, it's the same as anything else, where we get the aggregation trigger and the parent's created. We post the result, and then we do all the conversions, and then we print the label and so on. Our issue really is going to be involved primarily in this area here, where all the cartons that are coming in and seen by vision are supposed to make their way into the case after we pass the vision inspection. Are we all together so far?
Yep.
Yeah.
Bill?
Yep.
All right. Okay. So, let's take a look at how IPS Trace is going to see this information. So IPS Trace, it looks like this. This is what the icon for the executable is. I have it here. Let's open up one of the files. I believe it's this. Yep. So IPS Trace is the scope executable is going to see all the different blocks that are reporting information and then separate them out this way. And you'll notice that there's two categories. Ones that have a little dash before them, and these are the ones related to any I/O. So this is where we're going to find all the input data and all the output data. So any data valid, post results, any VIC input block is going to show up here. And then these, the ones that don't have the dash before them, are the ones that are not I/O related. So for this particular process, we wanted to make sure that vision reads, and when vision reads and passes, the rows make it into the layer area, and no rows should be taken into the layer area otherwise. So this is something that's very hard to see as the line is running. So having IPS Trace look at that for us was absolutely necessary. So it won't show you any data here unless you choose one of the blocks. So let's see which ones we should have. So we know that the whole process starts with vision. So let's see the case in feed, case row vision results. Okay, here we go. So this is the first vision inspection. Now, it's going to show you the timing of all of this stuff over here in the order that you check those boxes. So the first one that's here is case row vision results. Let's see case in feed row trigger. Or maybe let's case row push trigger. Let's go for that. And let's go for post row results. Here we go. So we have here, like, this is the first one we checked, this is the second one we checked, this is the third one we checked, and they come in at this order, and this is how they get displayed. So this is obviously like a lot of information, and to zoom in, you basically slide that zoom all the way in like this, and you can go really tight, where this whole span now is just 200 milliseconds in each one of these divisions. So you can go with really, really fine detail to look at what's going on. To aid us in this, let's take a look at also the aggregation block, just to associate all of this with a single case, because when this trace was taking, the last case that ran was one that failed aggregation because we didn't have all the cartons in the aggregation block. So I'll have this in there as well, just to give us an idea about where we're at. And the slider at the bottom takes us in time forward. Okay. Here we go. Let me take the zoom out a little bit more. That makes a little more sense now. Let's go back here. Okay. So the process basically is we got the camera inspection runs first, and then based on the result, the post result is going to show, and then after we post the result, the machine pushes the row in. So that's the basic process that needs to happen every time. The machine should not be pushing any rows unless we pass the inspection. And sometimes we will take an inspection, post the results, and the machine's not going to push because the inspection failed. So it's not going to push it in, it's just going to reject them. So it's not unusual to see, for example, this situation happen here where vision runs, post results comes in, and then there's no row push trigger because that just means that an inspection failed. So let's take a look at how this goes, and you'll find that for the most part, things will follow a specific pattern. And this is because we're dealing with machines. You're always expected to see patterns in IPS Trace. You go to the scope, and then you see, all right, this is how this works. This happens, and this happens, and this happens. And they follow each other in that way. And you'll notice some anomalies, and these anomalies are going to be the ones that you can kind of focus on and see, oh, something weird is happening here. And this will point you a little closer to troubleshooting the issue. So let's keep going. This looks fine. All of this is, it appears to be normal. Another aggregation started. Here we go. Now, here you will see kind of a break from the norm, where we have a row push that wasn't really preceded by a vision results. What this means is the machine at some point loaded a row of cartons without us having inspected those cartons. Now, that means that these cartons will physically make it into the case, but we don't know that they made it into the case. We never read them. So in the end, when this case gets full, we will think that it's missing one row of cartons at least. And in this situation, we kind of were definitely able to find out why we were failing aggregation. We were failing aggregation because the machine loaded a row of cartons without getting the results from us, without giving us a trigger to the camera in order for us to read those. And there was no way for us to really figure any of this out unless we used IPS scope. Now, what ended up happening here is we looked at how this was happening. We analyzed it with the Pester folks. This was a Pester case backer. And then the Pester engineer looked at his code, and we kind of found out exactly which situation in their code would lead them to pushing in a row of cartons without giving us the trigger first, and they had to make a change in their PLC program for the machine in order to fix that, because that's effectively a bug in their machine code. The machine code was missing a particular situation that caused it to push a row in order to keep up with the machine without giving us the trigger. And in the end, this kind of, it did two things. It had us working more in sync with the machine, and it also kind of proved that not all the issues that are seen on our system are because our system is being weird and funky. It was actually doing what it's supposed to do, and it was pointing out an issue that the machine was supposed to take care of. And this also enables us to review how the machine is implementing the timing diagrams that we sent them at the beginning of the project. There's always documentation. There's always timing that we send to the machine folks, so the OEMs would understand what kind of signals we will give them and kind of signals we will get from them, and how they implement it is going to be, it's going to look the same here, where we can actually verify that our design is being implemented correctly. So that's when IPS Trace and this scope is very, very important, is to be able to get the data and see it in a visual form that enables us to find out what's going on really well.
Eric?
Yes?
At that point, same scenario, if it was a trigger failure from our software, can we...
No, that's...
If there was a trigger failure at that point?
What was that?
Is it possible for us to see somewhere in between that and the one prior to that to see if there was a trigger failure?
Prior, for the case, you mean?
Indicator that we can turn on from the left side, as far as the
oh yeah. Okay, so which one would you want to? So we can obviously turn on any of these blocks. Now here, in this situation, we basically kind of proved that the machine didn't give us a trigger when it was supposed to. It didn't give us a vision results trigger and instead pushed extra cartons into the case without verifying with us that they're good cartons. And hence, we never added them to the aggregation block because we just didn't know that they were there. The machine should have given us a trigger so the camera can inspect those cartons and add them to the FIFO and in the end go to aggregation. But the machine failed to do that, and they had to fix the code in the machine in order for it to work appropriately. But obviously, you can turn on any of these things. So let's see which other one would you want to check, Bhavika?
Let's say the in-feed row trigger. I would want to see that to see if
this is the clear in-feed row trigger.
Okay.
So actually, the clear signals are very important, and I was taking a look at that as well, because in some situations we were getting clear signals that were, and that happened on a different machine on the same packaging floor. Like it was a different case packer. I was there, and then we had an issue with aggregation where we were also able to figure out that for some reason the first case, the machine would always send us a clear case signal right before aggregation ran. So we were always failing aggregation of the first case. That's another thing that we would have never been able to figure out unless we used IPS scope, because we were able to trace that clear signal and find out that, hey, just before aggregation, that clear signal goes high for some reason, and then we obviously have to fail aggregation at that point because the case to us would be empty. Here, you can see that we did get like a clear row in feed signal here, and that basically clears. So, and that's actually important here because you notice that we did pass a vision result and the machine didn't push a row in. So I guess they mirrored their reject signal by sending it to us as a clear in-feed row signal. So if we were going to pass these along to a different FIFO, that signal would clear it before it makes it into the new FIFO so that we would clear that particular queue, verifying that anything that we may have read actually didn't make it into the case. So tracing clear signals, I would say, is also extremely important because that's the way that we can verify that, you know, things that are supposed to be rejected actually got rejected. So here, another one where we had vision results and the row push didn't come in because actually they cleared that row. Here we go. So as you can see, patterns kind of always end up showing it. Like you always see patterns when we're dealing with machines, and it's very easy to verify that when anomalies happen and see why they're happening and where they're coming from. Now, one important thing about IPS Trace is that it will always accumulate. So it will keep records and keep adding to those records as time goes by. And I think there's a maximum of maybe 32,000 records in our software at the moment. And if you don't clear it, you'll end up having something like this where this goes all the way back and it tracked a lot of things. And you can clear it. You can do a clear and then load it again so that you have a clean one that you use. Let me show you an example of a fairly cleaner one that Bob had sent me. Let's see, I think this one is a little clearer and it doesn't cover as much time. It doesn't have as many blocks. This is for bundle. Let's see, bundle, child vision results. So this whole log is tracing a span of like, let's see, 45 seconds, about 45 seconds.
Mark, I've noticed for some reason when we ask for a log sometimes, they haven't done a clear of the logs. They capture the log that's been running for who knows how long, and they come in with a very short time frame, like there's nothing captured. And I haven't figured out why that happens once in a while.
Well, the log needs to have details turned on. And if details are not turned on, you won't be able to open it here and see anything. So a log like this, if we take a look at what's going on in it, you will find that it has all those details that we looked at before, where you got numbers moving in, the timing, and a lot of records being captured for all of this. The logs that don't have details, let me show you. I think I have one here. You'll find that there's not a lot of detail here. This is just a basic overview of what's going on. We loaded this file got loaded, all right, new lot, and lot ended, new lot began, this file got loaded, and some aggregation failures happening because of whatever. But you won't find nearly as much detail as something like this, where within the span of 45 seconds, you got all of this data because, Vision took a picture, and then it saw all these numbers, and then these numbers were loaded and associated to the number that was seen by Vision for the parent of these items. So if it looks like this, if it has all of this data with a lot of timestamps and information for each block that's doing this, you can open this in IPS Trace and it will show you everything.
There's one thing we do ask sometimes, Tarek. If there's a reproducible issue, we will actually ask the customer to go in and clear the log, then go and start a new lot and actually recreate just the issue itself, so it captures less data, but the exact problem. So
and it looks like this is what you guys did here. Like the example that I'm looking at right now is a very good one, because it looks like they cleared the log, they ran, and then they captured whatever issue happened here. Now, unfortunately, Bob didn't send me the IPS file for this, so I don't know what the hell's going on and what we're trying to figure out. But
sorry.
But we can see it's fine. I mean, this is another example of how IPS Scope is just going to show you patterns that repeat. So we have here bundle child vision results. So it looks like we're taking a look at all the children in a particular bundle. Let's see, there is bundle parent vision results. So I guess this reads the parent of these bundles. This reads the children. What else? Bundle pack, bundle complete, and post results. So let's take a look at these and just verify that there is some kind of a pattern. So we get bundle complete. So the bundler finished a particular bundle. It formed it. And then we are looking at the parent, it seems, and then we're looking at the children afterwards and associating the parent to the children. And then we post the result after aggregation runs. Let's take a look at aggregation from here. And yes, so aggregation will start basically right after bundle complete starts. We create the parent, we read it, we read the children, and then when aggregation is complete, it verifies all of this stuff and then posts the results. Let's see if something funny happened within this range. Same pattern, same pattern. Seeing the same pattern coming over and over again. So I don't know what kind of issue was going on here, if it was related to the bundle, or maybe it was a timing issue where you can also zoom in real tight here and see how long a particular process took. Or like let's say the time between when vision results for the children came in, and you can actually select a portion so that you can easily go back and see the range of time from here to here by seeing how the divisions go and doing the math, really. So it's really useful, not just for seeing when signals come in and out and seeing if things happen when they shouldn't. It's also good for timing situations and seeing if there's any anomalies in time between when things happen. it takes too long in specific situations or it doesn't. The other cool thing that you can see here is that you can take a look at timing statistics, and it's going to show you the statistics of time for how long things took within the range that we have here. It's also going to count the number of times we have rising and falling edges for these blocks. And it will only show you the ones that you have checked. Let's see, what else can we do here? You can take a look at the event log. It's going to show you basically the text version of what we're looking at here. So if you want to see, all right, let's take a look at the numbers at this specific point in time, you can go to that point in time based on the date and time span here and see what's going on and take a look at the numbers that were seen by the camera, all the bundle numbers that were seen by the camera in one specific bundle. So this is also a way to kind of see the data, not just the timing, and see if maybe we have some weird duplicates, maybe numbers are repeated more than once, or you can see if maybe we were only seeing 9 instead of 10 items in each bundle, things like that. Any questions?
I believe in that view you just had up there, you can actually do a search for a keyword.
Yes, there is a text filter, and we can say, all right, I don't want anything except, let's say, aggregation. It's going to show you everything that every event that has the word aggregation in it. So you can also be, you can save time by having it select only the data that you want to have. Let's say I only want to select things that, take a look at all the EDMC numbers that it picked out, and it's going to show us only the lines that have EDMC in them, so we can go through these different numbers that Vision read. So really, the important things about understanding how IPS Trace works and how to use it is make sure you understand IPS, like the actual configuration that we're trying to troubleshoot. Being familiar with it is really, really important in us trying to know what's going on and to know what we're supposed to expect, so that when we see the scope, we understand why things are happening and why things are supposed to happen, and why, if we see this particular anomaly, it would lead to a specific result. So being familiar with the IPS configuration, getting the log, getting a good clean log after clearing is always a good method to tell customers and FEs to go with that. And open it up, zoom in to the area that you know has the issue, and can kind of trace things and see where the anomalies are happening. That's basically it. Do you guys have any other questions? Bob, do you have anything else that you've seen that we haven't mentioned yet?
Now, I believe the scope here can also view your event log.dat file in here as well.
Yeah, you can totally do this. You can open, from here, you can open any kind of file that it can see. It's text files, the scope files that are created, and it can also open CSVs, because sometimes you can save, instead of saving in text, you can save it in CSV in IPS actually. You can also open the event log.dat files, which include not just IPS data. It will include the data coming from the system, errors that are coming from Screen Manager, errors that are coming from Vision, all of that stuff. Because that's another event log that our systems also keep. It's not just IPS, it's for everything. So you'll see in there critical failures from VizDev, critical failures from audit log if something happens. And then you can take a look at these and kind of find out what's going on.
Now, sometimes you can get a log that's like 32,000 records long. What I like to do sometimes is open up as a text file in the event log file as a text, do a search for the word error. 9 times out of 10, do the word error in there. It'll give you the timestamp when it happened, and you open your trace log up in the phone viewer, and you can go right to that timestamp, and it's easy to find it that way.
Yeah, that's cool.
It cuts time down just all through a whole big long screen flick of a pattern.
It's true.
It's little shortcuts.
But you said the log file actually has 32,000 lines of limit.
It can have up to 32,000, yes.
So what happens if there was 32,001? Would it overwrite the first line, or would it stop?
It would, yeah. It's a FIFO, so it will clear out the oldest and then put the new one instead. Yeah. Kind of like our circular buffer in Vision, you know, where it's also a FIFO. The first reject image is going to be reject number 1. You get a new one. The first one becomes 2, and then and it goes all the way down until the limit, and then the new one kind of replaces the first, and the last one goes away.
Right.
Any other comments, Bob, or questions? Bhavika, Bill, Rachel?
Nope. I think nope.
Pretty good.
Good informative.
No, it's good.
All right. Awesome. Thank you, guys.
I'll try to find out from Lee when that version changed. We were able to do it prior to a lot start, because it was the old one. You had to actually start your lot. You had to
do details every time you want it, and it would also always reset back to overview at the end of the lot. Okay.
We found
which makes sense at the same time. Like it's so we just need to figure out which way it goes so that we know how to tell you know what to tell customers.
Yep.
Cool.
Very good.
Thank you, Bob.
Great.
Thanks, guys. This was cool.